Well, hello and welcome to Math Blossoms, where growing in mathematics is natural. I am your teacher, Miss G, and for today's topic, we're going to talk about scatter plot graphs some more and also talk about lines of best fit and analyzing scatter plots. So let's get started with today's lesson. Okay, this is all about data analysis. So we're dealing with what we call a line of best fit. So what is that exactly? A line of best fit is basically a trend line. When scatter plots show a linear association, a straight line can be used to show the general trend in the data. So is it generally going up from left to right? Is it generally going down from left to right? We call that a positive association if it's going up from left to right, and a negative association when it's going down from left to right. If you haven't watched the scatter plots associations video, you should watch that one before you watch this one. That might help you understand it a little better. So a trend line or line of best fit is a straight line that should lie as close as possible to all of your data points, perhaps excluding the outliers, however. If you don't know what an outlier is, it's also explained in the other video, scatter plots and associations. Okay, so here's some examples. Which of the following shows a good trend line or line of best fit? And explain. Okay, so number one, I'm thinking that one is not a good trend line because if you notice, our data is going from left to right up, right? And they've drawn the line from left to right down. So this one's definitely not a good trend line. Okay. Number two, that one looks pretty good to me because it looks like it's going from left to right down. You've got several points above the line and several points below the line. Now, your goal is to try to get them a little symmetrical, like try to have similar number of points above and below the line. So if you count this, you've got 1, 2, 3, 4, 5, 6, 7 above the line and 1, 2, 3, 4, 5, 6 below the line. That's about as good as you can get it. It's not, your trend line, your line of best fit does not have to go through every one of your data points. It just needs to go in the represent the general trend, so to speak. So that's a good one, number two there. Number three, we do have an issue with this one because the trend line or the line of best fit has been drawn with most of the data points below. Excuse me. So when the trend line is drawn above most of your data points, if you go to analyze some of that data, you're going to overestimate that data because your line's above all of the data. And so that wouldn't be a good one to use. Same with number four. Number four, you've got the line drawn below most of your data. Since it's drawn underneath most of your data, you're going to end up underestimating your data if you're using this line to analyze the data and make predictions or estimates, which is what we use line of best fits for. We use them to make predictions, and we also use them to do estimates of our data. So the tool is only valuable if you draw it in a way where it resembles most of your data. And in number three, it's too high up. It's above the data. And in number four, it's below most of the data. All right, so overestimate, underestimate, I was talking about that. All right, now here is, why do we use them, right? So here we have some lines of best fit that have already been drawn. And we also have the equations that go with these lines of best fit. And it says we can use linear equations in y equals mx plus b form from trend lines to make estimates and predictions about the data. So here's an estimate, for instance. If I were to say in this first example here, the one on the left, if I were to say, what would be an estimate of, the number of boxes of cookies you would have on day 7, right? So if I asked you specifically about day 7, you're going to come down here to the x-axis. You're going to find the 7 day, right? You're going to follow it up to your line, okay? Just follow it all the way up to the line. And then you're going to follow it across to the y-axis. And you would end up just below the sixth line here, right? So you could say that on the seventh day, you would have 5, almost 6 boxes of cookies. Okay. It's not quite as high as the 6th box, but you would have over 5, right? But and on the way to 6 boxes of cookies. So that's what they're talking about, an estimate. And here, we'll do another one for this second one here. The second one, we have dollars in the savings account. That's my y-axis, right? And my x-axis is the months. Okay. So if I were to ask you, what month would you expect to have $250, right? Oh, not 250. That's too high. Let's do 200. Okay. So let's do 200. If I'm wondering what month I could expect to have 200, I'm going to take my 200 here, follow it over to my line. Okay. Follow it down to the x-axis, and I'm going to end up right here at 8. And I could say, well, on the 8th month, I would expect to have the $200. Okay. So again, you can make predictions starting from the y and going to the x. Sorry, estimates, not predictions. Well, both really. And then you can also make predictions starting from the x-axis and going to the y-axis. Okay. And here's another one. We've got, pounds of cat food, and it's a negative correlation here instead of a positive. And so you could say, well, what would you expect the cat food to be? How many weeks would it take for 20 pounds for you to have 20 pounds of cat food left over, right? So you would go to the 20, you would follow it across, and you would end up at, between the 2 and the 3 here. And that's going to be, 2.5 weeks roughly, So again, we're estimating. So it's going to be a little bit, it's going to be not as precise as if we're not estimating, of course. Now, predictions are where the equations come in, okay? Because as you can see, we've got all these equations down here that represent these, trend lines. And the equations help you whenever the prediction you're trying to make is not showing on the graph. Like all of these things I was asking about, they're already on the graph, like the 7th day, the 200s in the savings account, the 20 pounds of cat food, like all that was already on the graph. We just had to follow it over to the line, then follow it down or across and find the other variable. But what if I were to ask you, like for instance, on this one here, how many boxes of cookies would we have left over on day 13? Okay. Well, we don't know that, right? We have no idea because it's not on the graph, right? So if I were to try to find out day 13, which is somewhere, like if I were to extend this line, it'd be somewhere out in here, right? I can use the equation to help me with that. I can put this 13 in place of the x, right? I can literally substitute it in place of the x and then solve it to get an approximate idea of what my y would be. So this is -1/3. And if I multiply that times 13 and then add 8, it should give me my y value, right? So let's do that on Desmos. I have Desmos pulled up over here somewhere. Where did I put it? There it is. Okay. So if I were to put, make it a little bit, well, no, I don't, I just want to leave it smaller here. All right. So if I were to put, negative, let me do negative. Oops, I forgot to put my negative first. Okay. So negative, 1/3. Let's do the 1 and then the 3rd. Oops. 3rd. And then I'm going to multiply that times 13. And then I'm going to add the 8. I'm going to get approximately 3.7 if I round that up. 3.6 repeating. 3.7. So you could say on the 13th day, you could expect to have approximately 3.7 boxes of cookies left. Okay. So that's why the equations are important, because you can plug in X or Y values into that equation and find the other variable for numbers that are not on your graph. And that's what we mean when we talk about making predictions. Okay, let's do another prediction over here. Let's say, how many pounds of cat food would I have left over on week? Oh wait, this one's going, you're going to have less than 0. So let's do this one that's positive. Because once you hit 0 pounds of cat food, there's not going to be any more. And you're hitting 0 right here at, 4.5 weeks. It's right here at the 0 marker. So, so making a prediction for negative amounts of cat food is probably not a good thing to do. But let's see how many months it would take to save up $500. Okay, so here this graph only goes up to $250. Let's see how much it's going to be if we wanted it to be $500, right? So what is the 500 going to go in? Is it going to go in the Y value or the X value? Well, it's going to go in the Y value, right? Because that's what it's on the Y-axis, the dollars in the savings account. So we're going to put it in place of the Y. So 500 equals 12.5 times X plus 10. And once we solve this equation for X, we'll know how many months it's going to take us to save up the $500, right? So the first thing we would do is get rid of the 100. This is just solving an equation. If you don't remember how to do that, you can rewatch the equation videos that I made for you guys. And when I subtract the 100 from this side of the equation, I get 400. 400. Okay. Now I'm going to rewrite this equation up here. Okay. Now I have 400 on the left side of my equation. Whoops. My mouse isn't wanting to work. Equals 12.5 times X. And how do we get rid of that 12.5 when it's being multiplied times X? We have to undo that multiplication by doing the inverse, which is divide by 12.5 on both sides. Okay, 12.5 divided by 12.5 cancels out to a 1x, which is what we want. And then 400 divided by 12.5. What did I do with my... Let me find my Desmos calculator again. Here we go. Desmos Scientific. Okay, so what am I doing again? Oh, yes, it was 400 divided by 12.5. Okay. And that is going to be approximately 32. So you could say it would take approximately 32 months to save up the $500 based on the rate it's going here in this particular set of data. Okay. So that's basically how we use these lines of best fits. We use them to make estimates showing on the graph. We also use it to make predictions for either the X or the Y variable. Okay, so here's another one. It says Miss G surveyed some of her students by asking how many minutes they spent studying for their math test and their test scores. All right, so what is the slope of the trend line? Okay, so in order to use the equations for these lines, you have to remember how to write an equation of a line, right? So let's find the slope. Okay, if you don't remember how to find the slope, you can rewatch some of the slope videos that I made for you. But in this case, the easiest way to find the slope would be to use the y-intercept point here. Follow the line up until you get another exact point. Here's a good one, and it doesn't have to be a data point. It just needs to be a point on the line. And remember, every space on this line is a point. But we want an exact point, so we can use a whole number and not a fraction. And exact points are located on the line, but also on the corner of a square. So if you notice that little dot there, I'm putting it on the corner of this square, but it's also on the line, right? And so is this one. So if I draw my little triangle from each of those points, oops, I'm going to get a rise up of 1 square. But in this graph, 1 square going up this axis is not worth 1. It's worth 10. Like if you notice, it's going 10, 20, 30, 40, 50, 60, right? So that means my rise is 10. And remember, our slope is rise over run. So that would be 10. And then our run is 3 squares, and these are counting by 5. So this would be 5, 10, 15, 15. Okay, because again, this x-axis is not counting by ones. It's going 5, 10, 15, like that. Okay, and we can reduce that slope by dividing both by 5, and our slope ends up being 2/3. And it is positive because if you look at that line, it is going from left to right up. So we know it's a positive slope. If your trend line has a positive association, then that slope will be positive. If it has a negative association, the slope will be negative. What does the slope mean in context of the situation? Now, this is where it gets tricky because you have to think about what this number means in real life, in real world terms. Well, we know that the slope, and if you look at the slope formula, you can see this easily. The slope is always the change in your y over the change in your x, okay? And the slope formula shows the y's on the top and the x's on the bottom, right? So what is our y in real life? Well, that is this axis. This y-axis here is talking about test scores, right? So this up here, the y is the test score. I'll just put test. Okay. And then the x is talking about the minutes that are studied, right? This is our x-axis down here on the bottom. And so that's our minutes. So if I'm interpreting this here, this 2/3, I'm going to say that means that I can expect to get 2 points higher on my test score when I study for 3 minutes. Okay, so that's what this means. 2 points more for every 3 minutes that I study. And I know this because the minutes are the x and the y is the test score, right? What is the y-intercept of the trend line? So let me switch colors. Let's go to green this time. Okay, and now we're looking at the y-intercept. Well, if you look at where your data, your line of best fit, your trend line, where is it crossing the y-axis? Right here at the 60. Okay, now we know that that point is 0, 60. It's not just 60, it's the point 0, 60, right? All the points on the y-axis are 0 something, right? So this is my x value, which is my 0, and then my y value. And just like up above, they mean the same thing in this graph. So this is saying if I would expect to get, if I study 0 minutes, if I study zero minutes, I can expect to earn, oops, I need an eraser. I messed up. Okay, boop, boop, and boop. Okay, I will get a 60 on the test. I will earn a 60. That's earn. Mouse is not wanting to play right. Okay, so if I study only 10 minutes or only 0 minutes, which is nothing, okay, I will get a 60. That's what this data trend here is showing, okay? Now, is that true for every person in this data? Absolutely not. But because it crosses right there, that is the general trend, okay? Now, this person studied 0 minutes and earned a 75. That guy right there, right? So it's not going to fit every single data point, but we're talking about general trends, general trend in the data. What is the equation of this line? Well, we know that the slope was 2/3. We know that the y-intercept was 60. So we can put it together like this. Y equals 2/3 times x plus 60. All right. Using the line of best fit, what would you estimate to score on the test if you studied for 40 minutes? Well, this is actually on the line. Let's change colors again so we can do this in a different color. Okay, so this is actually on the line. If I go to 40 minutes, I'm going down here to the x-axis where the minutes are. And I'm going to 40 right here. I'm going to follow it up to my line. Don't follow it up to data points. Follow it up to your line, right? And then follow it across. And I would expect to get about, it looks like a 96, 97. So it says if you study for about 40 minutes, you can expect to get a pretty high score there, 96, 97. That's what it looks like, according to this data trend, okay? Another question is using the equation. So this time, instead of using the line of best fit, we're going to use the equation that we made to make a prediction of what test score you can expect to get if you study for 65 minutes. Okay, so 65 minutes. So let's plug that into the equation. I'm given 65 minutes, okay, and they're asking me what the score is. So that means they're giving me the x, and we got to solve for the y, okay? So plugging that into my equation, I would have y equals 2/3 times 65 minutes plus 60. Okay, and when I put that in my Desmos calculator, let's do that really quickly. I need to pull it up again. Desmos. All right, here we go. Oops, that's not it. There we go. All right, Desmos calculator. I'm going to do 2/3 times 65 plus 60. And that is going to give me 103.3. So I can expect to earn 103.3 roughly if I study for 65 minutes. And since most tests only go up to 100, that means that person who studies for at least 65 minutes is probably going to get 100, right? All right. So that takes care of that one. Now we've got this one. In 1960, 45% of the U.S. population smoked cigarettes. The percentage of the U.S. population that smoked cigarettes since the year 1960 is shown below. Here's the equation for that line. The equation of the line of best fit is written here. What is the slope, and what does the slope mean in context of the situation? Okay, so let's look at this slope. Remember, the slope is always the change in your y, right, over the change in your x, right? So what is our y in this case? Our y-axis is over here, and that is the percentage of the population, right? What is our x? Well, our x is down here, which is years since 1960, okay? Now, what does that mean then in the context of the situation? Well, that means since it's negative, we're talking about this slope here, okay? Since it's negative 5/8, that means, I'm not going to write it out because it's going to take too long and make the video too long, but I will say it. I'll say, what is the slope and what does the slope mean in the context of the situation? I'm going to say that let's do the x first, okay? eight years past 1960, okay. Well, let's do it this way. I want to explain it a better way than the way I'm about to explain it. Okay, you can expect 5% of the population to go down every 8 years since 1960. Okay, so because this is negative, you can expect 5%, because these numbers on the left here represent percentage, right? And that's my Y, right? So if it's 5, that means 5% of the population, it's going to drop. It's like less people are going to smoke after 8 years since 1960. So basically we're talking about 1968, right? Now let's look at the next one. It says, what is the Y-intercept and what does it mean in context of the situation? Okay, so again, I'm going to switch colors. We'll use purple again. Okay, here's my Y-intercept. It's right here. Okay, and I already know that it's 45 because it's right here in the equation, right? Now, what is that? That's 0 and 45, right? And that's the point on that graph. That point right there is 0, 45, right? So this is my X value. This is my Y value. So what is that telling you? That's telling you that 0 years since 1960, you can expect 45% of the U.S. to smoke cigarettes. And that's exactly what they have up here, right? In the words that they told us at the beginning. So that's what it's representing. 0 years past 1960, or in 1960, because that's 0 years past 1960 is 1960, right? So 1960, 45% of the people in the U.S. smoked. What is the X-intercept and what does it mean in the context of the situation? Now, X-intercepts are something that we don't talk a lot about in 8th grade, but I will go ahead and mention it. We'll use this one. Okay. It's when the line it's where the line crosses the X-axis. So if I were to take our trend line here and just extend it down a little bit further, okay, where it crosses the X-axis would be right here, okay? Now that coordinate point is the point 70 and 0, okay? Notice the X-axis always has, the Y-intercept always has a 0 in the X position, but the X-intercept point always has a 0 in the Y position. Isn't that interesting? Okay, so what does that mean? Well, since this is X and this is Y, you could say, well, 70 years since 1960, you can expect no percent of the population of the U.S. to smoke cigarettes. That's what that's saying right there. Okay. 70 years past 1960. So what is 70 years past 1960, right? Add your 70 to that. And we're talking about 2030. So by the year 2030, 0% of the population will be smoking cigarettes. If the trend continues, this data trend continues. This is how we make predictions. All right, using the line of best fit, what would you estimate the population to be in the year 2000? Okay, so let me erase some of this. What would I expect the population to be in the year 2000? Now this time we can use the line. So I'm going to, what color have I used? Here we go. So year 2000, how many years past 1960 is the year 2000? Well, that's 40 years, right? If you add 40 to 1960, you're going to get 2000. There we go. You're going to get 2000. So if they're asking about 2000, they're talking about 40 years since 1960. And that's right here. Okay. 40 years since 1960. So if I go up to my line, not to the data point, but to my line, and then cross it over, I can expect 20% of the people in the U.S. to smoke cigarettes in the year 2000. Okay. All right. Using the line of best fit. Oops. I'm writing all over the place where I'm having the, let me erase all this. Erase all this. Okay. Our last question. Using the line of best fit, what year would you expect only 5% of the U.S. population to smoke cigarettes? 5%. Okay. So now we're still using the line of best fit. I'm running out of colors. Okay. I haven't put red on the graph. So let's put red on the graph. Okay. 5%. So where's 5%? That's going to be halfway between the 0 here and the 10 right here, right? So 5% would be right in there. So if I follow that along the way till I get to my line of best fit, which is about right here, and then I follow it down, I can expect about 65 years since 1960. And if I add 65 to 1960, oops, that's a 1960. Okay, because that's about 65 right there between the 60 and the 70 right there. So that's, again, we're following it from the 5 here, 5% all the way over to the line and then down to the x-axis to find out where it's going to fall, right? And if you add those two together, you're going to get, you're going to get 2025. So in the year 2025, you can expect about 5% of the U.S. population to smoke cigarettes. Now, this is a lot of information that I'm giving you in one video. So you might want to watch this one a couple of times to get it right. But great job, you guys. Remember that we do use these trend lines or lines of best fit to make estimates and predictions about the data from scatter plot graphs. Remember that we can follow the X value from the X-axis up to the line and then over to the Y-axis line to find the corresponding Y value. Remember that we can follow the Y value from the Y-axis up to the line and then over to the X-axis line to find the corresponding X value. And also remember to use the linear equation y equals mx plus b of your line of best fit by substituting giving values for x or y to solve for the other value when making predictions. So in other words, if you know the x, you can solve for y, or if you know the y, you can solve for x if you have the equation. Remember that lines of best fit or trend lines can be drawn incorrectly. When the line is drawn under most of the points, the line will underestimate the data. When the line is drawn above most of the points, the line will overestimate the data. I think I went into that more in the first video, but I'm just reminding you in this one. And I think that's it, everybody, for this video. So great job, and it was lovely teaching you math today, and we'll see you next time.